get a screen sharing permission, please? Okay, I have it now. Thank you. Okay, can I get a thumbs up that you see my presentation?
Yes.
Thank you. Thank you once again for having me here. I'm really honored and delighted to have an opportunity to talk about open science and reproducibility in research. I know the talk says reproducibility in research, but I want to connect it with the main theme of this event. So as I was introduced, I am Malvika Sharan. Currently, I'm in India. I'm with my family and there's a lot of festivals going on. So chances are you'll hear lots of background noise, but I hope that won't be very disturbing. So a little bit about me. I have a PhD in bioinformatics. I really enjoy learning about biological processes. My PhD was in infection biology and RNA biology. And I had, in my process of learning and researching during my PhD, got involved in open access and open source through research publication, code development, and so on. In that process, I also realized that my PhD or my research isn't just my research. My research has to be reaching to as wide audience as possible, and I need to learn from them. As a researcher, I cannot work isolated in a way that I don't understand what other people need. And that's how I got involved in scientific training and collaboration. In that process, I joined a lot of open source communities and initiatives, which I'll talk about in a second. And in that process, I really enjoyed talking to people and facilitating their work. Research was interesting, but more than that, it was interesting for me to make sure that people could collaborate with each other and talk to each other. And therefore, in 2016, I joined a European Molecular Biology Laboratory right after my PhD. And afterwards, I wanted to work more widely in the Turing way, which you will hear about today. So the communities that I'm talking about, the first community I got involved in is an Open Bioinformatics Foundation. It is an organization that hosts yearly conferences where people come and talk about different bioinformatics tools that they are working on. And I am now in the board, and not just me, Caleb has just joined the board. Therefore, if you would like to hear more about it, please contact us. And we also offer twice a year travel fund, for which I chair. So I would really love for you to actually go and attend different events and learn about what people are doing. And if you have lack of funding, please contact us. Another community I got involved in is the Carpentries. I hope you've heard about it. So Carpentries teaches foundational skills for computation to researchers like you. And through that, I was really exposed to why it's important to collaborate in a global environment and why it's important to make sure that we are building our research for global collaboration. I also became a fellow for Software Sustainability Institute in order to carry on these aspects of community building and open science. And in 2019, I, along with Yo Yehudi and Bernice, founded an organization called Open Life Science that I hope you've heard about, because the BHKi is our favorite organization from Open Life Science. And also you will hear about it from Yo Yehudi tomorrow. So I'm giving you all these overview just so you know that I have a shared understanding of where you come from and the path that I have taken. I hope I can share with you so that you can choose your path carefully and identify ways to open your work for collaboration with the globe. So the 4 aspects that I'll be talking about today, first we'll start with that scientific errors have real world effects. And we have to start all our research from that understanding, and I'll go a little bit into that. Then I'll talk about guide to research reproducibility, which would be mainly talking about the Turing way and how we can enable your work to be reproducible. I will give you an overview of computational reproducibility, talking about from the perspective that you are all trying to learn about bioinformatics, and bioinformatics is a lot about computational biology. Therefore, you need to understand what kind of computational aspect you should be choosing. And finally, I will touch upon collaboration to enhance reproducibility. So reproducibility cannot happen on its own. You need to make sure that other people are able to reproduce. And this would be hopefully a segue for what you will learn tomorrow. So starting with scientific errors have real world impact. As researchers, we have an obligation to consider ethical and moral standards. And when I say ethical, it means basically taking the right action for right people and their impact on society. So everything we do does have an impact. We might not be able to see it all the time, but some examples can make you more aware. So I also want to give a disclaimer that a lot of things that I'll be talking about, you probably already know about it, or maybe you're hearing about it for the first time, or you are in a place where you know so much about it that you say, oh, it's too complicated. Wherever you are, whatever I'm talking about, I hope is useful for you, and you understand that different people are in different places, and therefore we will probably go slow in some places, or we will go fast in some places, but we should always ask questions. So first example that I want to bring about scientific errors have real world impact comes from this UK-based COVID track and trace app. So this is an app on our phone. I'm so sorry. This is an app on my phone and on everyone's phone in the UK, and we need to carry it with us so that we know if we have come in contact with someone who has got COVID. Recently, earlier this year, there were a failure in reporting about 50,000 cases. And the reason was that the developers were using Excel sheet, but an old format of Excel sheet. And I have to start from making sure that you understand why this error happened. So there is a National Health Services in the UK that exists for over 70 years, meaning that they establish a process in 1987, and that's the process they carried on until now. And they forgot to update it, even though they had decided at some point. And what happened because of this Excel related problem is that we underreported 50,000 cases, meaning that 50,000 people who should be self-isolating weren't self-isolating, meaning that more people had the chances to get infected, and more likely they did. And this was a common IT error that led to this problem. There were 8 days lag, meaning that there were people who had been probably come in contact with these 50,000 infected people. And this came in light only when people, public started to look at data and public started to notice that there is something off here. So this is definitely deadly for people who are vulnerable, who can get infected and potentially die. So this is an extreme example, but I'm talking about how a simple IT error can actually cause a really, really bad effect in the world. You can also say, oh, well, whatever we do, we should get peer reviewed, right? This is great because this is already a good step when we try to publish something that should be peer reviewed. But you should also understand that there is no point of taking your work to an expert after you've done a massive amount of work. So I really love this phrase, this statement, which says to consult the expert after an experiment is finished is often merely asked to conduct a post-mortem examination. They can perhaps say what the experiment died from, but they cannot really change it for you, or they cannot give you back the time and resources that you've implemented. So there's an example of that. In April, there was a research publication which was not peer reviewed. It was preprint from Australian researcher on COVID-19. What they were doing is they were screening thousands and thousands of approved drugs against COVID. And they found that one anti-parasite drug called ivermectin in the high dose could stop virus from replicating in cell. Now in Latin America, where there was surge in infections and there was no access to vaccine at the time for them, the doctors were desperate to save their dying patients. And therefore, when they read this paper, they started to use ivermectin for treating these patients. And because of that, several other different doctors, different people started to use ivermectin, not just in Latin America, all around the world. So just imagine, this paper was retracted in June, but between April and June, the practices that came out of it had really potentially caused life-threatening impact on the world. And why this happened is because they were using a faulty data set. And this came in light when a student in London was reading this paper and asked the authors for data. And once they started to look into their data, they realized that data is really, really faulty. And therefore, retraction later on is great, but then the potential harm has been caused. So what can we do? We need to avoid errors from the start. We need to know how we can avoid the error from start. And there are 3 errors that potentially leads to these kind of errors. First is mistaken research design or analysis process. You can be working in the same lab, and it's highly recommended to use the same standard and protocol that your lab is producing. But if your data set is completely different, that lab protocol probably doesn't apply to your research. And therefore, think about if the research design and analysis process is correct for your data set. Second is wrong choice of tools, statistics, and methods. You can't apply the same statistics on different data sets. Therefore, you need to make sure that the choices of tools are actually appropriate for you. Another is inappropriate baseline comparison. Baseline is what is control or normal behavior, and against which we are comparing abnormal or different behavior. So this is very important, especially when I'm talking to African researcher here, because if you study something from USA or UK, you need to make sure that you understand, is it really applicable to my geographic location? Is it really applicable to the resource that I have? Is it context driven? The context is, do the research environment where these researchers publish their work apply to my research environment? So this is where you need to consider the appropriate baseline comparison. So if you can remember these 3 errors, I hope you can start thinking about where can I avoid reproducibility mistakes. And with that, I want to say that most researchers, hopefully every researcher, have really good intention. They want to apply best practices, but we also need to recognize that it requires intention, resources, time, and collaboration, especially when you're young, when you haven't been previously exposed to different practices. And this can be a very overwhelming processes. A lot of time, hopefully, when you've been talking about open science in the earlier sessions, you might have felt, but this is my data. If I share, people will start judging me or they'll find my mistake. And we need to make that okay. We need to make that feeling of apprehension okay, and guide our researchers step by step in making sure that they're applying best practices without feeling overwhelmed. So whatever I talked about is not just about reproducibility, it's about any sort of best practices in research. And with that, I want to talk now specifically about research reproducibility. So research reproducibility is important, especially when you combine it with open access or open source. It saves valuable time in verifying and building upon widely beneficial solution. If someone is working in a different part of the country and someone else has an access to that exact research in the real time, they might be able to collaborate with you. That's great, but they can also build upon your work because they want to apply to a problem that they are facing that you may not be aware of. So in simple terms, we define reproducibility as when same analysis is applied to same data, it should give the same result. Replicability is another one where you have same analysis applied to different data, it should give somewhat similar result. If you're an experimental biologist, you might be calling everything that you create in different environment as replicates. And then there is something about robustness. When you have different analysis applied to same data, it should give somewhat similar result, then you know that this is reproducible. And then generalizability. But when we talk about computational reproducibility, we need to make sure that this minimum criteria is met, that the same analysis applied to same data gives the same result, not just to you, but anybody who uses it. And as simply as I defined it, I also know that's very, very complicated. So it starts right when you have a research idea that you want to communicate to others. You start planning your research, you design your study, you start collecting data, you process your data, and in that processing, you make decision around what kind of tools I want to apply, what kind of methods I want to apply. And you need to also be aware that sometimes your own biases can get integrated. And that's why when you apply it in association with different people, with different opinions and different backgrounds, they can hopefully avoid the biases that you may bring into the research. And then you conduct data study and analysis, you publish your data. After publishing, you want to make sure that your data is archived so someone else can actually reuse your data and build upon it. And this is quite a lot of things. how to do it, what tools to apply, where do I find information, who is going to mentor or train me, and all these questions. And I'm super aware that that is, again, super overwhelming. And this is where the Turing Way is playing a role. Turing Way is an open source project that involves and supports its diverse community in making data science reproducible, ethical, collaborative, and inclusive for you. It's an open source project, which means that this belongs to you, and you can use it in the context that is highly beneficial for you. This is a part of the Alan Turing Institute, which is the National Institute for Data Science and Artificial Intelligence in the UK. The book had started as a guide for reproducible research. And since 2019, we've been able to develop multiple chapters on the reproducibility. And these chapters don't go in deep detail of how to conduct computational analysis, but they really introduce you in a very gentle manner what open research means, what version control means, how you can learn about licensing. You already learned from Sarah about research data management. We also talk about that here. We have binder hub, quality control, code testing, and so on. So I would actually try to give you some time to explore this today, but this is just an overview of what you can try to learn. If you don't know where to start, you could always ask your peers and ask your supervisor so that you know exactly where to start. This book isn't written to be read from beginning to end. You should read what is important for you. It was started by Kirsty Whitaker, who's the director of Tools, Practices, and System program, as a lightly opinionated guide. So she wanted to make sure that the resource that we develop is targeted towards PhD students, postdocs, PIs, and funding teams, so they know what their responsibility of reproducibility is, where they can make an impact, and how they can make their work more understandable and efficient. There are added advantages of reproducibility. When you're doing your work reproducibly, you can go back in the history. You can track the project history without feeling confused about it. Because you're planning for your reproducible research, you know what exactly you're doing, therefore you know at what point what had happened. Other people can collaborate and review your work. You can also avoid misinformation. The open source, for example, or open science, when combined with reproducibility, allows anybody to scrutinize the work that you're doing. And the advantage is that they can catch any misinformation that might have creeped into your research, and you can fix it early on before it becomes a problem for others. If you're keeping all this information in a very organized manner, you're also able to write papers efficiently. And not just paper, you can create different sort of publication, which is blog posts and videos and talks and so on. Other is that you get credits fairly. When you are publishing your work openly and you're creating it in a reproducible manner, people know what you're doing. Everybody knows it because it's recorded somewhere. A part of reproducibility is that you write everything. And that's where nobody can take the credit away from you because everybody is aware. And then you can also ensure continuity. You're a researcher, you are curious, you are studying something today, you might not be studying that in the future. So you want to make sure that whatever you're doing now is actually available for other people who might still be interested in working on your work. But there are also barriers to reproducibility and open research. First is the reward system. So you might have heard in the academic system that there is a pressure of publishing a lot of paper, but we should be actually shifting the culture by making sure that we are producing reproducible paper, high quality paper, useful papers, and not just numbers. Novel finding is often given more credit than the finding for continuation and reproducibility. There's a high cost for publication, not in terms of just the money, which is already a barrier in a lot of places, but also in terms of how much time it causes you. Training and skill transfer isn't often paid for. This is not part of research often, and people do it in their own time. So as I can say, the organization that's organizing this event is doing it in their own time. They've invested so much amount of time in emotions and a lot of hidden work that goes into it. There's no compensation for that. And leadership. Often there are leadership in one manner that you're doing a PhD and postdoc and a further postdoc and group leader, but there are a lot of other leadership responsibilities that we have that we do not really promote. through reproducibility and open research. And then sometimes some institutions fail to adopt open source and reproducibility standards. If an institution sets a standard, everybody would do it. But if an institution doesn't take a strong stand, we are not able to do what is actually important. And lack of trust. Sometimes people think that if the paper is openly available, it must not be really high quality. So we want to avoid propagating that mentality of barriers. We want to make sure that you understand why reproducibility is important and how this can become part of your research process, that you don't feel it's an added work for you. And you can promote that through every work that you do. And again, you have to understand at what stages of research you are in and what specific tool applies to which research, what tools specifically apply to data, code, or result that you're publishing. And all these are available on the internet in different places, and we try to give access to those through the Turing Way in a centralized manner. So the Turing Way is a book. It's always a work in progress. And when I say work in progress, it's because we talk about research and data science, which actually evolves more rapidly. And when it evolves really rapidly, it becomes very hard for people to ensure that we are producing the state of the art, meaning that every year we might need to go back and update the recent tool that people are using. It's an open source project, it's a community, and it's a culture of collaboration. And I will touch upon each of it quite briefly. So a work in progress, it's not just the guide of reproducible research, but we also offer guide on project design, communication, collaboration, ethical research. And if you're interested in building your own community, we also document everything that we do in the Turing Way to make sure that we are demonstrating what we are teaching. It's an open source project because everyone can freely read, reuse, share, and build upon it. It is shared under open source license of Bspi and MIT. So Bspi is for documentation that we are giving, and MIT for the code and infrastructure. A part of open source project is also to make sure that you're building on other open source projects. It's not about always building novel research outcome, but for example, in our case, we work on Netlify, Git, Binder, JupyterBook, and we use a lot of communication tools. Other part of open source is that you're documenting everything. So we have a README file, which is a landing page about the research. We have a contributing guideline, code of conduct, and who our contributors are. And I'm showing you this is that I want to make sure that you can go back to the Turing Way to see how you can actually make your work open source. It's a community because we want to make sure that interested members join and contribute to the project. We build a collaborative pathway for them to come into the work and get credit for what they are doing. And they define direction and the goals collaboratively for the project. We have over 285 people, or probably at this point 300 people who are contributing to the project directly, and we have thousands of users. And these users come from all across the globe, and they are using it in their own context. So one of the reasons why I show this page is I want to make sure that you understand that the project doesn't belong to one person or me, it belongs to the community. And therefore, you're very welcome to criticize and challenge what we've written, because we want to make sure that we are producing right information that is actually applicable for your work. So talking about collaboration, we create pathways for collaboration where people can develop and share their work, maintain and improve, share resources, review others' work, translate the work, and also share their own best practices. We recognize everybody's work. And I'm showing you again, this example is because a part of reproducibility is make sure that you are recognizing everyone's contribution. So if you have to go back to them, you know exactly who did what. We use an all contributors bot so that everyone, including those who don't directly work on GitHub, can also get attributed. And we recognize all their contribution by recording it in a document. So a lot of time, I mentioned that there are hidden work that goes into developing a project in research as well as in the community. And we should have a way to recognize all of them so that they can use their experience of working in different projects in advancing their own career. And we also provide a lot of templates, guidelines, and resources to make sure that people who are not previously involved in the project can also come in. So this is another part of reproducibility, is that reproducibility doesn't just happen for one person or the team that is building it or the people who are going to use it at the end, but throughout the process of research, you would have different people coming in and leaving, and you need to make sure that you have a process to bring them in the same level as you. Now, talking about computational reproducibility, here I will mainly focus on some of the topics that I think would be very relevant for you, and these topics have been discussed in the Turing Way. So remind you about the reproducibility: when same analysis is applied to same data, it gives the same result. And we have a huge process, and each process have different tools and methods that are applied. So when we talk about computational reproducibility, 4 things are very important. First, that you know how to track changes for your code and resource, meaning the version control. Second, you know how to write clean, understandable, and error-free code. And here, even though I'm talking about code, you can also apply that idea into any sort of documentation and processes that you have. Save and share your computational environment so that if someone else has to run your code, they know in what environment did you run it. And make your code open for others to test and use. So talking about first version control. Version control is that when you make changes to your record in a file or set of file over time, you would have access to different version. And you can think about version as that I may give you a copy of a document, you write something, that becomes a second version of the copy. You give it to someone else, they delete something, that becomes third version of the copy. And you should know at what point, what changes were made, why they were made, and who made those changes. And the version control system actually allows us to track these information. Git is a way to do that locally. But GitHub, you would hopefully hear about it tomorrow, is a web interface where you can also do it without having to code locally. Both Git and GitHub allows us to change, to record the changes that we are making as a snapshot. It's a distributed version control system, meaning that it doesn't have to stick in one computer. It could be across different computers. We all can work on the same data set, and we all can push changes in the central repository, and everybody knows who's working on what. Git is very complex, and you don't need to learn everything. There are only 3 things that you can start with: is commit, meaning saving the change; push, when you make a change, you push it on the main repository; pull is when someone else made a change, you pull it into your computer. And the GitHub, as I said, is a web and desktop app GUI interface, which allows you to do it more simply. Yesterday in the Open Life Science, we ran a tutorial. So if you do not know how to use GitHub, I will make sure that we share the video with you and the material with you so you can learn about it. So this is definitely, in my opinion, most integral for people who are trying to learn bioinformatics or computational programming. Second, writing clean, understandable, and error-free resources. So in order to write any resource error-free, what you need to have, first of all, is a style guidance standard. Let's say if you are leading a project, or even if you're not leading a project, you're part of a project, you need to make sure that everybody understand what kind of document or what kind of code we are trying to develop, and therefore try to make sure that you provide a standard for that. So this is a way of managing, sharing, and communicating resources internally for your group. You should have a workflow protocol and convention, for example, how you want to write the file name, where you want to publish your code, where you want to archive your data, and so on. Formats, guidelines, and templates actually make the process super easy. So it takes a lot of time when you're developing it for the first time, but from second time onwards, it's a reproducible work, right? So anybody can actually reproduce what you did because you are providing them the basic framework for that. And automating the task to avoid errors. We are human, we apply error in everything that we do. So when you automate a task, you can actually avoid the error. Coding is probably the easiest way to do it, but there are a lot of non-coding approaches where you can apply the automation. So talking about code style guide, there are a set of convention on how to format code. For example, let's say if you're writing in Python, there is a indentation. You need to provide comments for every code you're writing. You should import the packages and describe it correctly. And you should name your variables, file name, and etc. In a standard manner. So this is also another example from Python. The code style guide, better than it's really important to start anytime when you're ready for it. It's now is better than never. So there is something called PEP 8 convention. You can look up about it. You can, for example, use different enforcement tool. One is called Flake 8 and another is formatting tool, which is black. So you can learn about this in the Turing way. So I won't go in detail of that. Another thing is code review. So once you've developed code and you're very proud of it, just go to someone else to ask them to review your code. So they make sure that what you've written is actually reproducible for them. And also it actually makes sense. So always useful to go to someone who has a little bit more experience so they can make your work a bit more efficient. I have a lot of coding mistakes which have been improved only because someone else was looking at it. And it is really rewarding. So this really makes you learn about coding and makes you feel excited about coding. And often writing code alone can be really, really boring. This can be done synchronously. So sometimes you can have lab meeting presentation where you share your screen and everybody is looking at it. And at the end, they tell you what they like, what they didn't like, how else you can improve your work. Or you can do it asynchronously, which is through GitHub. You put your code up, you tell your friends and colleagues to review it and leave comment up there. You can go back later and you can update your code. So both of these options are really great. And I highly recommend that if you're developing any code, sit with someone else, ask them to look over your code and look over their code as well, because this should be mutual. Code testing. So after review, you want to test that your code is actually working. So you should not skip writing tests because you're short on time. You should write tests because you're short on time. The short on time is that you don't really want to miss the reproducibility aspect of it. You want to really make sure that your code is doing exactly what you want it to do. There are some different things like sanity check through print. So sometimes you write some code and you write a print command to make sure that it's actually doing what you expect it to do. And you can do it more sophisticatedly by using assert function. Assert, for example, allows you to understand that whatever you're giving as input and whatever you're getting as output is exactly as expected. So there are many other types of testing. Again, I'm not going to explain that, but there is unit testing, which are individual unit testing for software. That then you have PyTest framework, you have smoke test, which is to make sure that basic functionality is met, and integration test. So individual units are combined and tested as groups. So this might seem jargon, and this is exactly jargon. And that's why I would expect you to go to the Turing way and try to read about them. Now save and share your computational environment. You've developed your code, you got your code reviewed and tested, and you want to now run it in an environment and save that environment for others. You can think about environment as your computer, but your computer isn't available for everybody else. So you want to create a virtual environment for other people to reproduce your code. One example is through Binder. Binder is a very simple way to make your GitHub resource available online so people can actually run it on their web server rather than downloading your code and trying to run it locally. We have a tutorial available for that, and hopefully you would be able to access that in the Turing way directly. Another is entire system. So in the past, we used to build virtual boxes or virtual environment, but they are very heavy. It's heavy because it's almost a computer, so you don't probably want to use that. Instead, you can create a Docker image for entire system. And another example is for Conda. The Conda is for Python package management that you can share with people. So this is a table. If you have a graphical, meaning that you can look at things, you can click on things, you want to create Binder or virtual environment, and you have a command line one where you want to create Conda for software and Docker for entire system. Take a screenshot or again, consider this as jargons, but these are something really important to come back to when you're thinking about reproducible computational environment. Finally, making your code open for others to test and use. So this comes from open source, of course. I already showed you that the Turing way uses framework for collaboration, peer production, and sustainability because we share our code under open license. So open source is literally about license. Free source software isn't always open, so you can make your code available on GitHub, but if you do not put a license, it isn't legally useful for others because they can't modify or reuse it. Open source also doesn't mean free, because you can charge for your open source software. You can charge for different services that your open source software does. So no license, legally not open. Open source is simply putting a license so that people can use it in a way that you want them to use it. And open source makes it easy for others to reuse and remix your work, and you get the credit. So here's a simple table again I built for licensing. It's a really complicated topic, and that's why I feel like this could be useful for you if you know what this means. So there are always two kinds of license. One is open license and one is proprietary. Proprietary is for only research. You cannot copy or modify it, and all the commercial licenses are using proprietary. In research, we recommend people to use open license because often our research is funded by public money, and research's overall aim is to make sure that all of us are advancing. So you want to publish it in a way that other researchers are able to use. But open license are also two kinds of license. One is permissive, where you allow people to use your code, use your environment, use whatever you're developing. You can choose, though, if you would like to be attributed. And I would recommend you to be attributed because you have worked hard. You should get the credit for the work you do. So CC by 0 is something where you don't get attributed. But you could use it in the public domain. So you could create a code which is very small. You think people would actually use it a lot and you don't really care about getting credit. You can put it on CC0. But CC BY 4.0 or Mozilla Public License or MIT and BSD, all of them are open permissive license. So people can do whatever they want to do with it, but you get the credit. Another is copyleft, where you force people who are using your code or using your data or using anything that you're developing to be published in open source. In permissive, people can use your code and data and also use proprietary, but in copyleft, you actually expect people to use open license. Reproducible research doesn't always have to open. So at the moment, I have talked everything about open and reproducible going together, but open source is actually a choice. Open access is actually a choice. Reproducibility can be facilitated by open, but you don't have to have everything open. You need to consider reproducibility at all stages, but you can think about if open should be actually applied in one case or other. For example, you should never apply open in private, confidential, or sensitive data. You should never apply open for things that you think that can harm other people. But you should always think about reproducibility. And when you want to simplify that, you can simply think about FAIR principle, which I hope you've heard in Sarah's talk, which is findable, accessible, interoperable, reusable. You might have heard it in the context of data, but you can apply FAIR principle also for software. You can apply FAIR principle for training material. All you need to think about is that people can find it, people can access it, people can build upon it, which is interoperability, and reuse it in their own context. You can also think about that if I want to open my code, maybe I open my code entirely. But if I want to open my data, which is the clinical data, I don't want to open my data. Maybe I give a dummy data set or synthetic data that people can use in order to test my hypothesis and so on. Finally, I want to say you are your number one collaborator. All the good practices that you're applying actually benefits you in the future. So you should think about yourself in a very selfish manner. I also want to say that open source, reproducibility, or any sort of concept that I have discussed today applies many things. And you should take the possible step that you require at this point and ask for feedback and help whenever you can. You've been brought together by these wonderful people. You should connect with each other. You should share your worries, share your challenges, share your successes, and ask questions. The reason to come to these workshops is not simply to learn and go away, but to actually build connection with people so you know who can answer your question after the workshop is over. Finally, collaborations to enhance reproducibility. I wouldn't play this video, but I would really recommend watching this video. It's about data sharing and management. It tells you the frustration that one experiences when your data is not reproducible, or when your code is not reproducible, or people cannot find different components of your research. And you have been there, I have been there, and we should not forget that we shouldn't replicate those experiences for others. We should replicate only good experiences for other people. Let me skip that. So what collaboration looks like, right? I have talked to a lot of young researchers and they say, well, I love to collaborate. I'm here to help you. Tell me what I can do, find me a task. But when you think about people who have passed through that, so for example, current me thinks about reproducibility and collaboration in terms of that, oh, it's not just about me asking other people to give me tasks. I need to consider how I can apply collaborative method. How can I transparently communicate my work? How inclusive is my approach? Am I co-creating my work with others? Am I actually collaborating with my teammates? Are my team members diverse enough to challenge me on wrong behavior or wrong research practices? And am I being respectful to other participants? So collaboration is a lot more than just asking for a task to be done in a project. So I want to also just simplify this for you. So you can have individual role, which is helping others. So someone gave you a task and you did it and you're done with it. But you can cooperate with someone. So you understand what we want to achieve in a long term, and you have someone who's telling you constantly what to do. But collaboration is actually connecting with every single dots in your work and trying to find a shared goal, taking leadership positions, not asking people all the time what to do, but finding what you can do, what skills you can build, what skills that you can teach other people. It's really a lot more than common goal, production, or team members. You should also think about, am I creating an inclusive workspace for my colleagues? Am I building a diverse team? Am I opening my work for contribution? Am I applying the right reproducible method? Who can I ask if that's not the case? There's a lot more to collaboration than helping or cooperating. This includes connection with other researchers, planning and conducting research, accessing for funding and resources, maybe not at this stage, but in some other stages. Also getting authorship for the research papers that you contribute to, expertise, policies and standards, data collection, storing and sharing. And you can think about all these steps are also involved in reproducibility. So reproducibility and collaboration also goes hand in hand. In order to make collaboration happen, you need to have clearly defined roles and responsibility. You want to make sure that you are creating a supportive work for each other. You are communicating your work transparently so that other people can read, understand, and reproduce it. You're maintaining highest ethical standard, and you're giving fair credits and rewards to different people. Reproducibility and open science require collaboration because none of this by default is inclusive, accessible, or community-led. So when you say reproducible, it doesn't mean that you're going to have inclusive environment or your work will be accessible. You need to have intentional mindset for community. You need to make sure that people you're working with, people you're producing for, are coming into the project in a way that is meaningful for you. So there are project design aspects that you should think about, and I'll not go in detail, but I highly recommend that if you don't know where to start, go to this chapter, which is a project design overview, which tells you before, during, and after the research, what you should be doing in order to make sure that your research is reproducible. And I've also created a worksheet for you for your hands-on activity whenever you get time, where you can sit down, choose a project that you're working on, think about what goals your project have, what shared goals and personal goals are there, what skills you have, what skill you can learn and teach, what uncertainty exists, what aspects of reproducibility you need to develop, what process of collaboration you should have, so you make sure that everything that you do is actually understandable for others. And I highly recommend that you do that. It's available in this link, which I would just drop in the chat soon. Finally, I want to say that everything that you do is for others. And this is a favorite quote of mine from Paul, who was my intern last year. He said that he realized that the value he left behind in the Turing way is not the amount of work he did, but how he enabled other people's work. So if you are interested in the Turing way, please join the community, learn a skill, share a skill, collaborate with mentor other people, and represent this community in your space so that other people know how to reproduce your work or how to build a reproducible work. I want to give a shout out that I am hiring a community manager and would love for you to apply if you feel that community management is your thing. And we are also hosting some of the events in the coming months. And the other link that I would share is bit.ly Turing Way, where you would learn all about it. Finally, I want to acknowledge Kirsty, who's the project lead, and Martina, who had developed the computational reproducibility part of this talk. And thank you for listening to me. I'll be happy to take any question you may have.
Thank you so much, Malvika. That was a very informative talk. And I have to say, like the animations, or rather the images that you used, they're so lively. I don't know how you generate that. I think you should share the secret.
Yeah, those images are available freely. So I would also add that in this. So let me make sure that I add this link where I will make sure all the things that I've talked about today is available.
Okay, thank you. So we'll take the questions after the second presentation by Pauline during the roundtable discussion.
Thanks so much.
Okay, Pauline, you're welcome.
Thank you, Maggie. I'm going to share my screen now. So just give me a thumbs up if you can see my screen. Can you see my screen?
Yes, we can.
Awesome. So I'm going to be talking about the Bioinformatics Hub of Kenya initiative journey. So initially, we were known as the Bioinformatics Hub of Kenya, but we had to add the initiative to it as we were doing the registration process. So welcome to our journey. So who we are. So BHK initially was conceptualized in 2019 at Bspi during a coffee break by our members Festus Nyasimi, Michael Landy, and David Kiragu. So over coffee break, they decided, or they thought it would be an amazing idea to create a community where bioinformatics enthusiasts and specialists can be able to just share ideas, content, code, and all that to be able to bridge the wide gap that exists still in Kenya and everywhere between novices and experts in the subject. So with that in mind, they formed BHK. They came up with the idea and then they shared it with Maggie and myself. And a few months later, they approached Dr. Masiga, Dr. Caleb Kibet, and Dr. Jean Baka, who are our mentors. And they shared the idea with them, and with a thumbs up from them, given that Caleb also had a community, had formed a community, Open Science KE. They were guided on how they would be able to go on, begin and essentially create a beautiful community to be able to achieve their goals. So why we exist? As I've mentioned, the idea was to be able to have a community where people could share anything concerning bioinformatics and basically interact with experts and build their skill. So we exist to build capacity, encourage networking through training, science cafes, and other social events. BHKi is a platform. The whole community is a platform where guys can come and just build their skill in bioinformatics. To create awareness on open science and the importance of collaborations. So given that we are a byproduct of collaboration and being guided and asking questions, we also want to do the same and create awareness concerning open science and the importance of collaboration, and to bridge the gap between aspiring and established bioinformaticians. So we wanted to also build a community where members could come and ask questions and get guidance, and through events like this, be sensitized, get a few links here and there where they can get information and such. Into our activities. So we came up with a few activities that we would be able to do to achieve our goals. So the science cafes are a monthly endeavor where we get our members to build their presentation skills. So our members basically get 15 minutes to 20 minutes of presenting their projects that have bioinformatics content, or any life science students are also able to present during the science cafe and get feedback from the other members who have attended the cafe on how they can improve their presentation skills and also collaborate and make their work better. The workshops, we have done 2 workshops so far. The R workshop, where we introduced our members to data analysis with R. That happened within the year. And one of the events also, part of the Bspi events, are other workshops where our members are able to build their skill. And yeah, conferences. So the culmination of the Bspi events is going to be a conference where it's going to be a networking platform. We're going to invite all our speakers who've been with us throughout the Bspi events, and there'll be and all our participants who've been part of all the events as well, and they can come and network and hear from each other. Yeah, basically just network. So that is one of our activities as well. Seminars, we also plan on doing seminars and annual AGM meetings. So we held our first AGM meeting this year, and we were able to communicate our plans for this year. And next year, we're going to do the same, have a brief report and communicate another plan for the rest of the year. So this is usually an open meeting, and we welcome our members to share their ideas and how we can make the community better and serve them better. So our successes and achievements. So from 2019 up to now, we've been able to have an average of 50 registered members for 2 years. And we encourage our members to continue registering. The registration fee is an annual registration fee, so it's renewed every year. So during the AGM, we had another 50 members register, and that has been consistent for the 2 years that we've been in existence. We are in the process of finalizing our registration as the hub in accordance with the Kenyan government rule. So we are registering as an NGO, and we will announce this once we complete it. Our first annual general meeting, as I've said, we held our first AGM in January this year, and we were able to communicate a plan for the rest of the year to our members. And we also got a number of new members joining in. We held our first introduction to art workshop. It was a 2-day event in collaboration with the carpentries, and we were able to train quite a number of participants on data analysis with our monthly science cafes. We've been consistent for around 5 months, where we held our science cafes. And once the pandemic hit, we did not go down with it. We actually became even better since we had to do it virtually. And we are proud to have been able to offer that and have quite a number of presentations. And I think this is our biggest achievement and success, which we were very proud of. We got our first grant from the Code for Science and Society, and in partnership with Open Science KE, we are able to present these events to you, the Bspi events. So the lessons that we've learned along the way: collaboration is key in science research. You cannot really work alone. So the whole BHKi is a team. It's a team effort. We are constantly in communication with each other, and we have a whole group where we're able to share ideas, share correction, correct each other, yeah. Ask for advice. We do not work alone. We work with so many other people. So that is one lesson I think we would love to share. You should network, and collaborate. That is the key to success in any community. So build a community with the people and not for the people. Involve them throughout the process. So even to come up with the idea of cafes and how we could be able to engage our community members throughout the year, not just waiting for big events or workshops. That came from our members. So to be able to serve them better, we need to work with them throughout the process and not just keep giving them stuff that necessarily not benefit them. So to know how to serve them better, we need to work with them. Have a dynamic team where each one brings their different complementary favors. Our team is very diverse. So we have David, who handles our finances and is very strict on that matter. We have myself, I handle the website. We have Festus and Mike, who are amazing in capacity building. And we have Maggie, who helps us write our blogs. So it's a team effort where we have to play to each other's strengths to be able to succeed. So even now, this presentation was not just made by me. Everyone had to chip in on how we could do this the best. So another lesson that we've learned as well is butting heads is unavoidable, but overcoming conflict has to be done in a healthy manner, which we have learned along the way. Being consistent being consistent as a team, and essentially not having anyone leave the team because of a fight. That I think that is also a very big achievement for us, and understanding each other. This is how this one works. This is how this one works. Correction, accepting correction and moving forward. That has been a very big lesson for us as well. And yeah, why you should join us and how you can join us. So the why is we have a number of institutional collaborators. So we have members from different universities, from different regions, and also in very many other institutions as well, who are able to guide us. So for example, our mentor Jean Baka works at ILRI and is able to help us out. Dr. Caleb Kibet, also a member at Bspi, is able to help us in a number of things. So the why is, if you would like to get a look into these institutions, we are able to provide that since we have amazing institutional collaborators. Our mentors are amazing, and they're always open to giving a talk, giving a workshop, handling a workshop, being part of the science cafes to offer better advice in terms of how you could do presentations better, which is amazing. So you should also join us to be able to meet amazing mentors. You can become a full or an associate member. So full members essentially are masters and postgraduate students who are undertaking bioinformatics as a course. And associate members are undergraduate students who want to know more about bioinformatics. So you can be able to join us and learn more about bioinformatics and find out how to plan your course in a bioinformatics career. And for the full members, you benefit from being able to build your presentation skills through the science cafes, where in the workshops, you're able to attend, and our workshops are moving toward becoming more advanced. So you're able to upskill and much, much more. So to become one of us, we have a monthly fee of 500 shillings or $5. And currently our only mode of payment is M-Pesa. So these payments that you make to become a member essentially help us to carry out the activities of the hub. So for example, holding the cafes. Sometimes we appreciate our speakers through honorariums. These payments essentially help us to do that. So for more information, each one of our members is on Twitter, and they are constantly tweeting out content about BHKi and the activities that we are doing. So these are their tags. And we also have a website, an active website where you can get more information, and it has an events calendar where you can get specific dates for all the events that we are carrying out. We also have our YouTube channel where we upload all the videos. Even for this event, we're going to upload all the videos to the Bioinformatics Hub of Kenya Initiative YouTube channel. So thank you very much. We are open for questions. Maggie, back to you.
Thank you, Pauline, for that amazing presentation. I think at this point, you're going to take a short break of 5 minutes. So we'll be back here at exactly 12:15. Yes. Walk around, stretch your legs, take some coffee, and prepare some questions. Hello, welcome back. So as a reminder, please add your information, your name, organization, and Twitter handle in the HackMD document. Mike is going to share the link in the chat. So we now start our Q&A session. Mike, please stop the timer.
Yeah, just a moment, I'm doing that.
Okay.
Yeah.
So now we start our Q&A session, and I will hand over to Dr. Caleb to take us through. So welcome, Caleb.
Thank you, Malvika. Thank you, Margaret, for that. Thank you, Pauline and Malvika, for the wonderful, really presentation on research reproducibility and the importance of collaboration. Really, that was a really insightful and practical presentation, which, in addition to just highlighting the need for collaboration, the need for reproducibility, the importance of reproducibility, you also provided a direct link to some of the resources that anyone who is interested in starting off when it comes to practicing reproducibility. And I just want to start off on Malvika, and within this conversation, we are going to bring on board all the BHKi steering committee, Mike, Margaret, Pauline, so for this conversation, so that we can also get to hear the experiences. So we've also heard that Malvika is really strong into community building, and they've built an amazing community of the open life sciences, and I've benefited myself from their work, and I've also contributed some level as well, being a mentor there. And really, I've learned a whole lot, a ton of how to run communities and how to run meetings and so forth from Malvika and the team. So thank you for the great contribution that you are making to the various communities, and also being able to support other communities that are upcoming through the Open Life Sciences and even beyond. And just by agreeing to come and speak to us today, it's really been an amazing pleasure. So thank you, Malvika. Yeah,
Thank you
pleasure.
so much,
So,
Caleb. Just want to say that I'm so proud and so honored with the association that we have with this organization and the team behind it. And there's nothing that I can support. It's a very selfish reason to collaborate, because I learned so much from what you all do.
thank you. So I think so I'll just ask the audience if you have any questions to Malvika or to the BHKi community. Please feel free to share the questions on the chat, and also you are welcome to raise your hand, and I'll give you an opportunity to also voice your question. So I'll just start with a question to Malvika, and really on the aspect of reproducibility and the need for reproducibility, and it's a question of what were the challenges that you had when you were starting off and practicing a reproducible and collaborative research, because that's where you started as you moved towards community.
I have a couple of examples. First, I will give my PhD was in wet lab. And if you're working with wet lab researcher, a lot of time computational research and wet lab research are not very synchronous. You might want to publish your software much faster than the data is ready. And therefore, one of the issues of reproducibility was to make sure that the data that I was working on in the lab is reproduced, as well as my software is applicable to other sort of data, which is where I needed to use public data set. And I had to use that because I wanted to publish my software much faster than the lab generated data, because the lab generated data needed validation. So I would say the reproducibility in this case became a pathway for me to actually expand the scope of my software, that I wasn't limiting it to this one single data set where I was going out and testing it on public data set. So though it was a challenge at the time, I kind of felt quite empowered that my research was actually more important than the lab that I was working on. Another problem that I didn't tell you, I wasn't really developing my code on GitHub. I put my code on GitHub when I had to publish my software, because I wasn't told from the start that this was the best practice. And it was a lot of work, and I wish I didn't have to do it, because when you put everything at the same time, people you're collaborating with, you're putting so much work on them because they need to review now the 1000th line of code when they could have done it in smaller chunk when you were doing from the start. So I really don't want anybody else to reproduce my mistake. Please do not. Just go ahead and start working on GitHub. If you're not ready to publish online, you can also create a private repository as a student.
Thank you for that. And I think the major challenge for most people is the fear of putting their work out there, and the fear of being judged and so forth. And so how do we ease now how can someone who is just starting off ease into practicing reproducibility and sharing their work openly? What's the pathway that would make it like easy and manageable for someone to start off?
I think what you all are doing is what we need to be doing. People shouldn't feel alone. They shouldn't feel that they are the only one experiencing this. We all worry about our work being online, even though we write it so much. I wonder if Maggie can tell us how many times she needs to read her blog post before she feels comfortable putting online. So we all feel that fear, and we just want people to know that even the experts have that fear. So your fear isn't isolated, and nobody's going to judge you if you are proactively collaborating and sharing your knowledge and sharing your research failure as well as successes.
So thank you for that, and I think that's really true. We can all start somewhere, and really everyone, even the most experienced of software developers, are still afraid, but they do it anyway.
Yeah, I just want to actually quote you, Caleb. You always bring this United Nations sustainability practice of leave nobody behind, and I love it so much, because research, as you know, Maggie and Pauline both were saying, that you cannot do it alone. And if you feel the fear of putting something online, maybe trust a friend, trust a colleague. They can assure you if things are ready to be online, because sometimes a second voice is so important.
Absolutely. So thank you so much. I'll just move the conversation, and we can please, in the audience, please ask questions, especially on research, reproducibility, collaboration, and if you have a question on where you can start. And I think you've pointed out to so many resources, but I'm curious about what are some of the other communities, because you say the most important thing is be able to not working alone, joining communities that are doing the work and sharing. What other communities can someone join? One, to have a community to work together and collaborate and share together, but also communities that they can join to learn and the skill that they would need to be able to practice some of these principles.
So one thing that I want everyone to know, that Caleb and I have in the past a lot talked about contextual research, how it is important to be represented in the global conversation. I come from India, I work in the UK, I have so much opportunity. And because of that opportunity, I'm able to collaborate with people across the globe. And the one reason for you to actually collaborate in the global organization is to represent your community, bring your own practices and be proud of what you're doing and show us what you're doing. So I think don't join somewhere because you want to learn something. That's an output anyway. You would definitely learn, but also go that this is your responsibility as a researcher in Africa to represent your work. So some example that I can give is Open Life Science, which Pauline had just mentioned, where they all have been mentored. And when I say mentored, it doesn't mean that you learn something new. You actually get accountable space to build something that you're thinking about, and people take pride in what you're doing and celebrate your success and connect with others. Our next call will actually open in December. That's one community you should definitely go to if you don't know where to start, because we are very well connected with different communities that you can go to. Another is the Turing Way that I just mentioned. This is really your project, I would say. Just, you know, feel confident that whatever you want to do in there, I'll find a way for you to get involved. Other places I would look at is Mozilla. Caleb is a Mozilla fellow, and Mozilla does every year a MozFest. MozFest is just a festival of different projects that's happening. So sometimes it's not about joining a community, but finding another person that is doing a work that you want to do. And you want to find that person by being in different places. It's an unfortunate time because of pandemic, but I've also learned that this is a fortunate time to be present in events that we couldn't in the past because we can't travel all the time. So take an advantage of that. If you are interested in joining a particular community and you don't know where to go, ask Mike or Caleb or Maggie, Pauline. They would ask us, or they would ask somebody else, and they can pass the knowledge to you. So these are three communities that I mentioned, but the carpentries has really changed my mindset about the community, because carpentries not just teaches you, but makes you feel that you can teach others. And that's a very good place to be in. So you're not learning because of which is true, you're learning for yourself, but you're also learning because you feel responsible for other researchers. So that could be really a beginner level community that you can be part of.
Yeah, thank you so much. And that's really true. Those are amazing communities that are doing amazing work in just onboarding and just allowing us to grow and participate and contribute and be part of the conversation and contribute to solutions and just also provide our perspective. And I think what you've mentioned is that we all have something to offer. That's actually something that's really important. We all have something to offer. Go to that post, but join that space and contribute and grow with the others. So thank you so much for that. And as we move towards community and the conversation about the importance of community building, the importance of participating in communities, I would like, and I'll start with you and then transition to BHKi team, to speak to the importance, and I think one of the presentations you made recently was on the need for communities to really work together and collaborate. Can you speak a little bit more to that? Why is that important?
Are you asking Pauline?
Yes. No, I'll start with you on that question of the importance of communities collaborating and working together. And you've been spearheading this conversation.
I absolutely love that concept, mostly because I often talk about community in basically as an analogy of the communities that we live in. So think about your local community where you are connecting with your neighbors and you're passing on the resources that you have. When your neighbor needs it, you're looking out for your neighbor. We can think about that in scientific perspective, that I am in a scientific community. I need to know my neighbors, what other neighbors in the science are doing, what resources do they need, what resources do they have? Can we exchange those resources? Can we actually collaborate? Because research these days do not function alone. We need to be cross-disciplinary. We need to know technology as much as science, as much as citizen science. You need to be able to talk about your work. So this is why I think you should think about the research community in terms of how you perform in your own society, in your own village, in your own neighborhood. Learn from what you do in your neighborhood. Can you do that at the scientific level? So in one sentence, if I can say, not every community have the same amount of resource. So we need to be aware that can we actually be more resourceful by collaborating and reusing things that they have done or giving them things that I have. So this is why I think the community should work together. Mostly because I come from I work in a very privileged scientific community. I know the resources that they have. And I have also studied and lived in India, and I know what resources a lot of Indian researchers lack. And that is very inequitable. So from the equity perspective, we need to really be collaborative. That's all I can say, that you shouldn't think that my research and my community is more important than someone else. These are all people, they're all doing the same work. So we should be supporting each other.
Wonderful. Collaborating. So it's not just collaborating within a community, but between communities and among different communities. It's a really, really powerful concept. Mike, I'll turn on the conversation to you and BHKi, this amazing community that you've formed, and it's been really vibrant and active in East and Central Africa, and your representation is even going an impact also going beyond Africa as well. So can you tell us a little bit about what was going you through your minds when you thought about starting BHKi? What gap were you trying to fill?
Yes, so at the time when we're thinking about building up this community, we actually thought about building the gap, because initially at the moment we were starting to aspire to be bioinformaticians. But again, there was always that gap between already established bioinformaticians and aspiring bioinformaticians. So that was one goal even in the beginning, that how can we bridge this gap so that we can have a platform where we have these mentors that we're looking up to. And as we aspire to get there, then we have a space where we can actually interact, learn from them, and then they learn from us. Yeah, and so that is one of the main goal that we had. And then trying to also, reach out by creating awareness, collaboration, as Malvika has emphasized about, having a space where we have an identity that we are always having this goal of data analysis in bioinformatics. So what are the things that we can actually build together and helping each other, achieve in our projects, in whatever we do in research? Yeah.
Beautiful. Thank you for that, Mike. Pauline and Margaret, you'll answer this question as well. So when Mike and the team reached out to you to join the community, can you tell us why did you accept? How was that resonating with your more or less interest and objectives, and how was been your experience being part of BHKi? Pauline first.
I think what I would say is I identified with their need to create a place where novices can build a strong foundation in bioinformatics, because your foundation determines how far you get. So being able to have all the information you need in one place about a subject and being able to reach mentors, I really identified a lot with that. So it was an easy decision to join the team. Yeah, that's what I would say about that.
Thank you. Margaret?
I think for me, it's like what Mike has said, that we were starting at the time. So you kind of feel small when you're starting, because again, if you look at the reality that bioinformatics is still quite new in Kenya, there isn't even many universities offering the course. Now they're taking it up, but then it was quite new. So when they approached me, I felt like, okay, when you feel small and you're new at something, and then there's people asking you to join a community, there's strength in numbers. And even like some of the things that I've learned is that the importance of building networks and collaborating. One thing that I've learned over time is that you do not have to reinvent the wheel. And that's the power of collaboration. That's the power even of reproducibility. You build up on something that somebody else has done. So coming into this space and coming into a space where there are people who have already made it, so to speak, or they're on their way, then you kind of, and I'm at the starting point, then I can see that it's possible to do it. And being in a community, you get the resources, that is the training, you get the exposure, you get the network. So yeah, I think that has been my experience so far. And that's what I love about even this community. And also another thing, maybe I've not mentioned, is that at the time there wasn't such a community here in Kenya. So it was even like, I was like, wow, we can start this and bring all the people together who might be feeling the way I was feeling. Yeah.
Wonderful. Thank you for that. And I think as you started this community and coming into community building and working together, how did you grow your personal capacity as a team to be able to start and run such a community? Any one of you, Mike, Pauline, or Margaret, can answer that question. Or you grew your personal capacity to be able to run a robust community?
Okay, so I'll mention this. So at that time, it was actually very coincidental that we have this idea, and then Open Life Science program is actually beginning. And it was really interesting. And I'm not mentioning this because we have one of the co-founders in the meeting, but I remember that time, Caleb, yourself, you actually introduced us to the mentoring program. So this happened towards the end because the idea came up in 2019, around August, September, thereabout, and then we started immediately the mentorship program. Yeah, so we started that all through the following year, and then we become, so with mentorship, you get a lot of skills, the reproducibility skills, that everything that we've discussed during this seminar. So those are the skills that we gain, and how to actually build a community, and that was really, really something for us. And the good thing is we actually joined all of us, yeah, and I would say OLS had really, helped us really to achieve this goal, into actually making this possible.
Margaret, Pauline, any additional comments?
I think I will touch. Okay, go on, Pauline, please.
Also, we had to learn how to create a positive work learning environment for our members, which is a key factor in any community. So we had to also be part of the carpentries and learn how to train, so to be able to create a better working environment or learning environment. Maggie?
I wanted to touch on collaborations and building networks, even for us to have reached out. And we were lucky, we were in a space where we knew somebody like Dr. Caleb, who knows these other people who are doing something close to what we were doing. So we were able to form networks and collaborate with a group like Open Science FAIR, which we're even collaborating with in this event, OLS, carpentries, to host some of our workshops, individuals like Jean Baca with resources. I think that has been one of the things, because when you start an organization and it's a group of young people who are starting this thing, and you don't have, especially funds. There's time, but there are no funds. So having people who are willing to chip in, that was amazing. So I think that has been the thing that has really accelerated us.
Caleb, maybe if I can add something, towards Open Life Science. I think Malvika has mentioned this during the talk, that there's going to be a next call. I would really urge, the participants today who have actually joined Open Science. It's really not specifically like you have to build a community for you to join. Even if you have a small Open Science project that you need to, be mentored on, just come up with the project, do the application, and I assure you, all through the 6 weeks, you'll gain a lot of skills. Even more to that, you can apply in even your day-to-day activities.
Well, thank you for that. I think that's really powerful, the importance of just that, and what you're speaking to some level goes into mentorship. And I'd like for just your team to just, Mike, you can just speak to it, and Margaret can follow, because you talked about that, the importance of mentorship when it comes to growing anything as a researcher, community builder, and so forth. Can you speak a little bit to that, Mike and Margaret?
Yeah. So I think for me, mentorship is, especially like if you identify a mentor and you know your goal, if it is in research, you know, a specific goal. And so someone who is always on your case, meeting frequently, because I found that we say that we have mentors, but really we don't engage with these mentors time to time. So for me, it's really important. It is important, yes, to say you have a mentor, but again, it is also important to always follow up with your mentor. Yeah, and how do you even now start to think about who is going to be this person that is going to mentor? You already know what you wanted for your life, for your career. So I think for me, guidance from your mentor is really important. Yeah, it could be your supervisor. It could be someone else that is not in part of my team. Like for my case, I have a mentor who is actually not part of my supervisor team, because perhaps I have different goals in research. Yeah, so really knowing whatever you want and then identifying a mentor and constantly following up with your mentor.
Thank you. Margaret?
I feel like Mike read my mind, but I think what I can add, the importance of mentorship is accountability. And you have to remember that mentors sometimes they're busy people, so they won't have one-on-one time with you all the time. I have learned over time as well that sometimes mentors are people who you're watching at from a distance. Could be somebody you're following on social media, but you really aspire to be like them professionally, or it could be somebody who's mentoring you on a one-on-one basis. And so this is where accountability comes in, because this person is going to be your sounding board. That you can go to them and ask them questions. So I think the importance of mentorship is that when you're starting, like I said, you do not have to reinvent the wheel, and you don't have to do it alone. You can find somebody who's doing what you want to achieve and follow them. So that, and it could be from a distance, or it could be on a one-on-one basis, and that's how we are going to grow, and that's how even we are going to grow our capacity in research here in Africa. We look maybe at the people in the West, what are they doing, and try and implement it here. I hope I've answered your question.
Yes, yeah. Thank you, Margaret. I'll switch a little bit to the aspect of still within collaboration and building communities. And I'd like for you to just share your experience in how you experience in applying for funding, especially to run this series of events. What has your experience been? Pauline, let's start with you.
I think what we learned during, so first of all, we had applied for one grant as just one team and we did not get it. But we kept on, and being able to collaborate in the writing of this new one, we were able to see the mistakes that we made when we were writing the first one. So collaboration essentially taught us, okay, so this is what you do. This is how you need to write it. Meeting the deadline, that was entirely a factor of collaborating with Open Science KE and pushing each other towards writing it to meet the deadline, sorry.
Thank you. Margaret?
I think since Pauline has talked about collaboration, it was a collaborative effort to even compile everything together. I think I can touch on mentorship again because we had you, Dr. Caleb, to help us. You are one of our mentors, and so you were there to guide us and show us how to, not like really how to, but just guide us through writing the grant. So I still take it back to the importance of having mentors.
Thank you. Mike?
Yes, so let me try to shift the question a bit, not talking about collaboration in the aspect of writing grants, but what we have plans for collaborative, especially when we're actually doing our scientific research. So to our members, this is something that we have not laid down so far. So the aspect of study groups, this is something that now will foster the collaborative working, especially when you're doing research, to achieve quality research within our members. So what we have been thinking about is coming up with different study groups, either metagenomics, RNA-seq, different types of groups where now we can identify members, who are actually interested in those kind of groups. And then with that, we also extend the collaborative working as we always, create awareness about.
Yeah, thank you. I'd like to bring Malvika back on board to the conversation around the question of, so in addition to just funding, what are some of the other pathways to sustainability when it comes to communities, and to build communities? How do you ensure that these communities are sustainable and continue to have value to their members beyond, say, for example, funding or the startup?
So first, I will actually start with what BHKi is doing, taking a minimal training cost when you don't know what the external cost could be. But a lot of time that could be a barrier. So our effort in Open Life Sciences to provide micro grants to our participants so they can participate, but also provide a little bit funding for their project. And that also came actually inspired through BHKi, because when BHKi was trying to launch, we hadn't considered it. And through the conversation, it became very clear. But also, this I'm talking about from my limited understanding, but there are a lot of funding organizations that are offering smaller funding. So start with something small, mostly because if you could prove that you found funding for a small work, you can show it as a successful example. One thing that it would happen that you will get rejected a lot, therefore reach out to someone with a bit more experience in writing grants so they can review your application. It's very important that you do that, because people who've applied several times have also failed in the past, and they really know what the problem could be. There is a portal called Open Grants. It's oagrants.io. I'll also add the link for that, where people publish their successful and unsuccessful application from different sort of funding resources. So you can learn two things. One is that what kind of funding resources are there, and also what kind of application have been successful. A couple of examples, I would say the Code for Science and Society, I'm in the selection committee of that, and we are just going to start opening the third call. They offer up to $20,000, so you can ask for 5,000, 10,000, 15,000, 20,000, given what you try to do. You can ask for person time as well in there. Then once you start getting like small funding as successfully as possible, you can think about bigger grants. In terms of sustainability, other things could be that you actually ask for your employers to allow you to work on your project by some %, because you don't want to burn yourself out. Working volunteer job is really, really hard. So if it can become part of your actual ongoing work, and if you could show the importance in your work, and your supervisor really appreciate that, it would really, really be helpful. Because one thing you need to be aware that working on your research and working on different projects can be really time consuming, and you should always think about how can I actually combine them. So that could be a good way of sustainability. Last thing definitely is bring as many people as possible. So you are not the only one doing everything. Bring accountability. Mike said that the whole team went together to get the mentorship because they were trying to build a common identity. So don't try to build hierarchy, because when you do that, a lot of work will fall into the person on the top.
That's beautiful. Like, when you build a capacity, when everyone is empowered, we can all really easily work together and contribute quite efficiently. Mike, I think this question of you applied for some time and you did not go through. Can you speak a little bit to rejection and how did you handle it?
I think for me, I didn't take it as a rejection. It's just that we didn't like make, because the application was supposed to do like the event for one person and we're coming in as a community. So really that was one of the disadvantages we had. So one lesson to learn is read your requirements for any grant that you want to apply. So that was a mistake, I think, from our case, but we're just trying it out. Yeah.
Can I just also say, just because of what Mike did, so Mike did that for the Open Bioinformatics Foundation, and I was the person to be blamed because I asked him to. And even though he didn't get the funding, we could have a very crucial conversation in the organization that these funding are required, that nobody is working alone these days. People are working in groups. So it doesn't make sense to make a grant for one person. And it took us really a lot of arguments and discussions and heartache, but we were able to convince everybody on the board that this is important. And they wrote a proposal which hopefully we can work with Caleb on to launch. So Mike, even though you failed, you did something wonderful. So I'm really grateful for what you did.
Really, we can see the impact, like being able to create change through that without even knowing. That's really wonderful. And I think we're almost running out of time, but I want to get to the question, that really important question that Sarah has raised here. Sarah, would you like to voice the question? Mike and Pauline.
Yeah, she can speak now.
It's gone.
Oh, she says she's in a noisy environment.
Oh. So Sarah asked the question, how do you measure the impact of your organization? That's to Malvika and also to Pauline. So Pauline, can you go first?
Right, so I would say the number of applications to the events and to the anything that we do has been one of the biggest ways that we measure how impactful we are being, and even the number of registered members. The fact that we don't have to convince them by doing a lot, that has also been a key way in which we have measured the impact that we are making. Yeah, I would say that has been and the growing mailing list.
Wonderful. Thank you, Pauline. Malvika?
Yeah, so impact is very important because that's where you're going to actually convince your funders and different people to become part of your organization, and you need to communicate that. So what Pauline just said about, counting the numbers are important, that there are more people coming in. You also collect feedback. So you should have a feedback from participants in some ways or others. So you're collecting their experiences. So a lot of time, number isn't enough if it's not quality. So you need to reflect what's the quality of your work. Another thing that you would hear, that often number or growth isn't the indicator for success. You can have as many people as possible and you might grow in number, but if you're not delivering the quality work, it isn't helpful. So sometimes you should limit the number of people you're able to invite in a workshop and maybe repeat. So the number of demand could become your indicator rather than the number of people coming into your project. We have a report that I can share how we measure the impact of the communities. Sometimes you just have to set how you say, the RSS feed for your community, because randomly people mention it here and there. And the more they mention, the more you can become aware that your resources are being used. So for example, number of citation. So if you can publish your reports, publish your blog, you can actually look at the number of citation. And some example of getting citation would be to get a DOI. So again, coming back to reproducibility, if you can publish it on Zenodo or Figshare, you get a DOI, and people can use the DOI where the number is counted. So that's one another thing. I could give an example from the Turing Way. The Turing Way was used by the European Union paper. It was used in a policy. It was cited by 10 papers or more last year. And those became a way for us to show the impact. In Open Life Science, in the first, second, third round, we saw lots of increase in number. In the third round, we were like, this is too much. We can't handle this many people, and these many people cannot get to know us personally, and we want that. So we reduced the number for the fourth cohort. So that was also indicator for us. But because we could show this growth to our funders, we started with zero funding, and now we received a lot of money to actually hire a full-time person. So people really appreciate the amount of work you do, the feedback that you collect, the number you can show them. So be mindful that impact is very important. And if you don't know where the impact can be assessed, ask different people what they want to know about your community. Great question, Sarah.
Wonderful question and really beautifully answered. Thank you. I think if there are any more questions, we can just ask, but I think we're almost at the end of this conversation. But I'd like to ask Mike and your team, what should we expect from BHKi? Where do you see BHKi in the next year or two?
I would say more visibility, like even Malvika said, like being impactful in our community, growing this community as well. Yeah, at times it gets overwhelming, by the way, but as you know, Malvika says, you get a lot of applications and stuff, but moving forward, this is, and one good thing that I realized among our team, about almost half of us are actually motivated about capacity development. So this is something that even within, it's a driving force that we need to make this moving forward. Yeah.
Can I just steal a second to reaffirm what
Yeah.
Mike said, that when more people come into your project and take leadership, I think that's the huge impact. If 10 more people can join Mike's initiative, and Mike doesn't have to work as much, having a free time is such a reward. So if you really want to show the impact and support these people, just join them, help them conduct training, because they can't be doing it all the time.
That's really good, Malvika, because you actually captured the question. The next question is to this team was, anyone listening here and they'd like to really contribute even much more and participate even more within this community and create impact? What are some of the pathways for your members to come into the community? What are some of the things that you would invite, you're reaching out to? If you have this kind of skills, can you please join us to do this and this? What are some of those pathways?
Yeah, so actually it's something that we already started. So in our steering committee, we also have, like, each and every one has someone that they mentor to do. Yeah, so we started with the small roles like organizing seminars, yeah, where the organizing secretary has a mentor that will handle those kind of trainings. So I think now the work has started to be reduced. So we have that team already in place. Yeah.
Wonderful. Anything else to add, Pauline, as we went down? Those who are interested in joining, where is the link? Where is the registration link? How can they register? How can they participate? Pauline?
So Mike has posted the links. We'll just post them again. add content to our GitHub pages. That's an amazing way where we could be able to get information on how we can do better. Our emails are working and they're in the website. So send us emails, send us ideas on how we request for trainings on what exactly you would like to be trained on. And we would be very happy to do that.
Thank you very much, Malvika, Mike, Pauline, Margaret, and your amazing team for really the great work that you're doing in building communities that are having impact beyond what you guys are doing, just beyond Kenya, beyond Africa. So that's really quite commendable. So final word from each of you, and as you answer that question, you can also speak to the question of anyone who is interested in forming a community, starting a community. What should they be thinking about? Why should they think about doing that? I'll start with Margaret, then Pauline, Mike, and finally Malvika.
I think my parting shot would be open science networks at the grassroots levels or higher can unite to more efficiently influence the researchers, the research world, to add greater adoption of open and reproducible resources. Like, sometimes institutions or organizations have not yet adopted these practices, but if we can make a lot of noise, in quotes, we are going to have influence and they're going to catch on, because this is always it's all about raising awareness, really, and it's all rooted in paying it forward, like Malvika put that quote there, pay it forward, make it easy for the people who come after us. Yes.
Wonderful. Pauline?
And communities helping other communities. So we are a success story because of other communities. So if we can just continue doing that and adding on to how we can build other communities, not just having one place in mind, we will achieve a lot, and it will be an amazing thing that comes out of it. Yeah.
Lovely. Mike?
For me, I'll stress on networking, building your network, especially in your community. It's really important, even in your growth in your career. And one thing I believe is that you increase your knowledge by sharing whatever you are actually doing. So let's continue the network.
Lovely. Malvika?
I would like to highlight that we are working now in a global environment. However, we should think locally. We need to make sure that what we are building is immediately applicable to people we are working with, but we should also apply those globally by collaborating, just pulling on what all the three, Margaret, Mike, and Pauline have said, to collaborate more widely, so you know that your work isn't limited to one context, but is highly contextual for more people. So reproducibility will allow you that and learn through practice.
Wonderful. So thank you so much for the amazing conversation, wonderful presentation. Really, I think we've all learned a whole lot from your presentations on research reproducibility, collaboration, and the importance of building communities, communities that can have impact, communities that are accommodating and bringing others on board, and just ensuring that others can also contribute. So thank you very much. A round of applause to our amazing panelists.
Thank you so much.
Thank you. I'll hand over everything back to Margaret. Margaret, you're a panelist, but now back to the sharing. And thank you for the amazing sharing this morning and afternoon.
Thank you.